All right, time has come to understand quantum entanglement. So, quantum entanglement, what is it? Think first about what we can do with gates. Yeah, we can get to a bunch of states that look something like that, or like this, and so on and so on. But there is a state that we'll never be able to reach, which is on the left and on the complete opposite on the right. Yeah. Why we cannot reach it? Because that will require us to be able to move something further. That's the puzzle gamer type of explanation, yeah. But what's actually happening behind? What does the mathematics entail? So imagine we are Alice and Bob. Alice has a qubit, Bob has another qubit. Alice is qubit 1, Bob is qubit 2. If Alice measures 0, she knows right away that Bob will measure 0. If Alice measures 1, she knows right away Bob measures 1. Yeah. So it's kind of a state in which you know that by measuring one of the qubits, you immediately know the other state of the qubit. So it also completely different would be also an entangled state is the opposite. Yeah. So if Alice measures 0, Bob measures 1. If Alice measures 1, Bob measures 0. This is also entanglement. This is part of the class called Bell states. They were shown in laboratories. They're working all the time. We find them everywhere in nature as well. We've been studying pulsars. We've been seeing them all over. That's a huge wall of text, and I think that's really necessary to explain the concept. There is no joke behind it. This is one of the most bizarre things we have in our universe. So again, as the puzzle gamer, you have to move one of the sigils while the other one doesn't move. The only way to move just one of the sigils is to use control gate. You see the difference? It breaks the symmetry of the visualization. This means that only part of the visuals will change, not all of them. So it doesn't matter what I put on X gate, everything changes, right? The only way to get away from that situation is adding control gates. You see, I'm destroying or I'm adding more changes to the forge. So if there is no control gate, everything just goes wherever it's supposed to go. But with the control gate, some lines just stay vertical. That's what you need to really be careful about. And if you want to move one, the furthest you can move it, just add X's everywhere, add the control of the qubit that's in superposition, and that's it. You got your solution. So all these puzzles are quite trivial because they are very context-based. It's about building the Bell state. So as I said, totally opposite is also an entangled state. So just doing this, again, you have an entangled state. In this situation, how can you get the red one? Well, let's think about how the fact that the only red we can add to the circuit is the one within the H gate. So we need to use that and then just build the entangled state like that. But then we also would need to make this X to make the counter states, yeah, in which Alice measures 0, Bob is 1, Alice measures 1, Bob is 0. Yeah, so something like that would also work. And for the last puzzle, again, doesn't matter how many qubits there are. If it's far apart, just make sure one of the sigils just goes to the other corner, and that's it. This is a Toffoli gate, and this is quantum entanglement.